Mm, 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 mm. Uh, 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 um, okay, okay. Morning, everyone. Welcome to this session number 477. And today we continue, and I hope complete this problem is the most profitable path in the tree. Currently, I am very close to solve, but I discovered that I have one incident uh, with this problem. One moment, please. Okay, as a summary of this problem, basically you have one array like this, or is a matrix where basically this represent a tree. Yeah, and you have, for example, the 0 is connected with the 2, the 1 with the 4, the 1 with the 6, the 2 with the 4. It's not a binary tree. This is important. And well, in essential is that, for example, 0 is connected with the 1 is connected with the 2, the 1 is connected with the 3, 2, and the 2 is connected with the 4. Now, every node, yeah, for example, the 0, we have another array with amounts, and every node have a specific amount, could be negative or positive. For example, the 0 is less 2, the 1 is 4, the 2 is 2, the 3 is less 4, and the 4 is 6. Even you can see these amounts here. Okay, what is the play, or what is the game in this case? Well, the idea is that you have two players, Alice and Bob. Alice all the time start in the root, means that the index 0, in the node 0, because the nodes are labeled from the 0 to n-1. Yeah, in this case, Alice all the time start in 0, and Bob could start, for example, in this case, Bob in the node 4 or in the node 3. Well, it's another parameter, but Bob start in another position. Is guaranteed that start in a different position than Alice. Yeah. Now the game with this the game in this problem is that you need to calculate what is the maximum profit or amount that Alice can reach in general in all the three were reach and live. Yeah, for example, Alice have in this moment two options, because this is a leaf and this is a leaf, the 2 and the 4. Yeah, what is the maximum profit? Well, you can take this value, and this value, basically this path, and the result, for example, is 4. Yeah, now if follow this path, the result is 2. Well, this is cancelled, less 2, in this case is 4, 2. Okay, now what is the purpose of both? Well, in essential is that where you are the first player, and both players move at the same time and at the same speed. Means that, for example, Alice is here and Bob is here. Okay, move one node. In this case, Bob tried to move upward and Alice tried to move downward. Yeah, in this case, in one step, one step. This means that the same speed and the same time. Yeah. Now, what is happening here? Where the first player that cross or that reach the node X node basically pay or win the amount. For example, do you imagine that Alice start here and Bob start here? Alice is the first player that reached this position, means that, well, obviously both start in 0. Yeah. In this case, 0, the Alice. And Alice have 0 less 2. Well, now it's less 2. And for Bob, is 0, 2, starting 0. 0 less 4 is less 4. Now, what is happening? Where Alice move in this direction, for example, here, basically Alice doesn't need to pay for this because Bob paid before, yeah? And in this case, similar with Bob, where Bob reached this value basically disappeared because previously Alice paid for it, yeah? Now, another rule is that where both players reach the same node at the same time, basically it's divide. For example, in this case, Alice is here, Bob is here, and in one step, like this, both reach the same node at the same time, and basically it's divide. For example, 4 between 2 is 2. Okay, 2 positive to Alice and 2 positive to Bob. Or where is negative, for example, do you mean that is less 4 is the same? Is less 4 between 2 is less 4. Okay, Alice paid less, well, is the amount of Alice less 2, and for Bob is the Bob amount less 2. Yeah, this is the game. Now, what is the trick with this? The trick is that here mentioned that it's a tree, but this is a graph. It's not a tree. Or is more easily solve this problem if you think that this is a graph. And now, for example, this is a graph. Why? Because it's in this case it's a direct graph. Yeah, it's not an indirect graph. Yeah, because basically the 0 is connected with the 1 is connected with the 2, the 1 is connected with the 3, and the 3 is connected with the 4. It's direct tree or direct graph. But for us, or in my case, I am transforming this in indirect graph. Means that I can move in any direction, 0 to 1 and 1 to 0. Why I do this? Well, basically because we have a few cases that are weird, like this. For example, let me use this. Oh, no, I have this text here. In one moment, please. I need to take my previous solution. I will replace for my current. What's happening here? Oh, I had this idea to solve, but this is wrong. No, I think that maybe is this. One moment, please. Okay, let me check. It's this case, for example. Here, I got 21 of 31 test cases that passed. But what is the problem with this? Well, the problem that I figured out with this case is that zero, 2, 1, 4, 1, 6, 2, 4. It's exactly this. The problem with this is that in my approach, I am trying to, the first is, I think that works, but the problem is with Bob. Why? Because, for example, let me write this 0, and I draw as a graph. Yeah, in this case, 0, 2. The one is 1 with 4, 1 with 6, 2 with 4. Okay, for example, here 4 is connected with this, with 2. Okay, I will create the arrows. 0 to 0 connected with 2, 1 with 4, now with 6, 2 with 4, and now 1 with 4. Now 1 with 6, 2 with 4, 0 with 2, 1 with 4. Okay, this is wrong. No, 1 with 4, 1 with 6, 2 with 4. Okay. Now 3 with 6, 3 with 7, 5 with 7. 3 with 7. And what is the 3? 3 with 6, sorry. It's here. Here, for example, we have another 3 is connected with the 6. The 3 is connected with the 7. And the 5 is connected with the 7. But you imagine that is this. It doesn't matter this draw. Now, in this case, I am doing this. Yeah, I am adding these arrows. But previously to this, I was or I am saving the, for example, I transversal all this array in essential. I am okay. I am saying that where you find this symbol, I am I have one map of Bob. Yeah, where I put the second value, for example, the first appears this. Okay, is 2, and the parent is this. Now the next that is 4, and the parent is 1. Now, for example, here appear the 4, and I am stopping in this moment. But this is wrong, and well, let me explain why. I save this. And next to, I am trying to follow this this map. For example, okay, the parent of 4 is 1. Okay, move to the 1. Now, move to the next. In this case, doesn't appear. It doesn't. I start. I take this value. 4 in this case, and I am trying to following the parent, yeah, to reach the 0, or in this case the root. But this is wrong because, for example, in this case, have 2 parents, and now the question is that, how you know in which direction you can go, and even, for example, here you can have more childrens, yeah. What is the right direction to reach the parent? Because if you know, for example, in this case, we know that the right direction is connected with the 2. Basically, I am doing this. Okay, 1 step in this point, 2 steps, 3 steps. And where is the tune of Alice? Basically, I ask, okay, how many steps have Alice? 1. Okay, where Alice it's minor than Bob, Alice pay completely or take completely the value of 0, that in this case could be positive or negative, yeah? Where R equal like this, basically is divided between 2 and it's enough, and where Alice is greater than Bob, don't do anything, yeah? It's cancel it, yeah? Don't take the value because Bob paid for it previously, and where the value is 0 because, for example, in this case, Bob never visit this nodes. Well, basically means that Alice need to pay or need pay for it or receive the award over the award or the amount, whatever. But yeah, the idea is that, or the problem with my algorithm is that I don't know what is the right direction. This, or this, or this, or this, or depend of the children's or the parents that have the Bob node. And for this reason, my code works with a half or the most of the test, but not with this. Because in this case, the 4 contain 2 parents, and where for example, I detect the first time that appear the Bob node, I stop. But even if I continue with the second node, in this moment, I don't know what is the right direction. Yeah, one way is basically transversal all possible directions. But this is It's expensive. I don't like this idea. I don't like this idea because basically, for example, if you have many paths, do you imagine that a bigger grab? Well, basically is so expensive. Yeah. Now, how can I solve this problem? Well, I have one idea that is basically tracking the parent. The first, and even I was doing in my whiteboard, I think that is here. Is this. But my idea with this is the first is create the graph, sorry. And in this case, for example, the black arrow means that the original, yeah. And let me create another, and the gray arrow means that my arrows, yeah. Basically, with this I convert this direct grab as a indirect grab, means that I can move in both directions, yeah. Now, what is the next? Next is basically mapping until search this node, yeah. For example, I have one moment, please. Like this, king and value. And basically this is the child, and this is the parent, and this is a list, yeah, and this is an int. Now, what is the next? Okay, the next is start in the index 0. Okay, it's in the index 0. I am here, yeah, and basically the first time the 0, the parent of the 0 is less 1. Sorry, this is the key, and this is the node. Is the 0, and his parent is less 1, yeah. And now, for example, is go to the get the child of this. In this case, is only the 2, yeah. Now, the 2, his parent is the 0. No, sorry, the node is this, and the parent is 0. And now move to the children. It's children or child? I forget. Well, move to the next. In this case, is the 4. It's only the 4. Okay, for example, the 4, his parent is 2. And in this moment, stop this. Why? Because in this moment, I know what is the path for reach the root. Because initially, it's only take this or with a while and ask, okay, what is the parent of 4? Okay, the parent is 2. Okay, move to the 2. Now, what is the parent of 2? Is the 0. Yeah, and in this moment is a stop. And you know that for the 1 is 1 step, 2 steps, 3 steps, and is all. And this is much better that transversal all the possible paths, even if you, yeah, it's much better because, for example, this case is 1 in 2 steps, you discover this, but with the previous approach or with another approach, basically it's transversal all the 3, and in this case is 1, 2. Another option is 1, 2, 3, 4, 5. And do you imagine that you have more here and more here? Well, it's basically increased a lot and it's so expensive. And yeah, and that's it. And keep the original code and only modify this. Yeah, because works. My code works, but the problem is only with Bob. Or I hope this. Okay, now, sorry, I need to respond something. Okay. Okay, now it's time to do this. Pop step map. I think that I can follow this. I can use this, sorry. But instead, no, use this. In this case, remove this, remove this. Wow. Okay, now here. I need to start in the 4. No, I start in the 0 and I need to check. Okay, in this case, Bob is in the 4. I think that integer Bob, no, pointer. Pointer is in 0. Yeah, because it's the root. And sorry. Now I am in the 0. I need transversal all the nodes. Okay, for this, Bob map. And Bob step. Okay, I have both. Okay, Bob map. Dot put. In this case is the node that is 0. Always start in 0. Even I think that I can use this 0, and the root is less 1. Okay, and now here is pointer is in the index, is in the node 0. I am here, and I need to get all the children's for this case integer n double point. What is the graph? The graph is map. Okay, map.get. Do you remember that the map contains the children's, the connection between 0 and 1 and 1 to 0. And is a list. Okay, it's only map.get pointer. I am saying this moment, give me all the children. Give me all the children that have the node 0. Okay, in this case, for example, return only the 1. But in this case, I need to discard that the children that has been processed before. Why? Because, for example, the 0 is connected with the 1, and it's only have 1 children. But, for example, the 1 contains three children, the 0, the 2, and the 3, because it's an indirect graph. I need to discard the 0 because has been processed before. I can reuse this scene and here reset the here reset. But here, for example, if scene dot contains n but negative, obviously, and here is a scene dot add pointer. Where is not contained. I think that I can create another function. Here is private void go path to root. Yeah, and in this case receive the node, they get steps, and in this case this is node. Yeah, where it's not for example, this is the node 0, the steps is in 1, whatever. Node is different at 1, yeah, okay. Add the node to the scene, and now give the children of this node, in this case, for example, the 0 only contain one node. That is this. Okay, in this case, for example, the one has been processed before, no, okay, to the DPS, okay. I'm not sure if it's right, the DPS or maybe BPS. I have this though, but well, in this case, I received this and the steps. Oh, well, in this case, steps plus plus. Yeah. And that's it. Only with this, I can create a map with the, and this need to stop until I have, for example, to receive the 0, and the 0 go to the 1. Got it. Now the 1 contains the children, the 2 and the 3. For example, go with the 2. If you imagine that the 2 contains another children. Okay, the 2 and is mapping, whatever. Now the next that is this, the 3. Where appear the 3. This is a stop, but the problem is that this can continue because it's in the stack trace. I think that with a BCS, if this is not a while, it's a simple. It's enough with this. And only validate if node is equal 4. Of node basically is return, don't do anything. But here the problem is with this, because if these have more children's, basically here it's stop here but continue with this because it's a DPS. No, I think that I need to use the, yeah, maybe I need to use the BPS, because using the BPS, basically I am in this level. What is the child, the children, sorry, is only 1, okay, continue. And for example, we reach this, we're in the moment that appear the Bob node, in this moment is stop, and you can, it's not continue with the next. Yeah, I think that is much better the BPS. In this case, with the BPS, do you remember that we need a list with the elements? I need a list with the BPS to save the nodes. I think that with the stack, it's only a simple integer. Stack, it's equal, no, this is Q. New linked list. I forget all the time who wrote this. Linked list. Yeah, it's right. And in this case, it's enough with this. Now the next that is q.add. In this case is I don't need this because the node is 0. Take node starting 0. I add the node. And now the next is a while, and I need to ask where a node is different that Bob node. Yeah, what is different to this? And now, in this case, I need to get the size of the current queue. Yeah, and now I need a for. And for this for, I need to transversal this integer I it's equal 0, while I it's minor that size I plus blah blah blah. And now in this moment, for example, is the node 0 contains the queue contains only one element, means that is only one iteration. And now I need to give the children, sorry, children is plural, children is the plural of child. Okay, given the children's of node n. Yeah, and in this case, I need a for integer c double point map, because the map contains these values. Map dot get n. In this case, get a list. And the first is that if scene dot contains n, no, c, but negative, okay, you can add in the queue. I think that this is not necessary. Let me check. No, yeah, it's necessary because it's an indirect graph. Yeah, q.add is add, and in this case is c, and that in the 0 contains only one children. That is the one hasn't been processed before, means that I add in the queue. Now the queue contains 1, is a stop, and is a stop, and now continue with the next. But the problem is that the node is in which moment node Hmm. This is wrong. In which moment? Which moment I return this? I think that here. Or and I need to get the n. In this case, n is not defined here. Yeah, sorry, I forget this. Integer n, it's equal. No, and I think that I can use node. Node, it's equal q dot remove, and now I know in the moment that appear at this, perform the operation, but in the next iteration is stop it. Up, almost here. Now it's node here. I can contains adding c. Now, for example, I am in the zero. The zero is different than 3. Okay, the size is 1. I add this node in the scene, and I say that I am saying that okay, remove this element, and now iterate one time, give me the children's of the children of the node 0. In this case is only 1, and but before to add I need to validate that hasn't been before, hasn't been processed before. In this case it's not, it's new. Okay, add, and it's stop it, and it's stop the both force, and now Q contains only one element. Okay, now nodes contain the value of 1, yeah, because has been no, the 0. Now the node is 0. No, this is wrong. This is wrong, because if this is 0, I add the 0, and now I am removing the value of this. I have the size. I think I can add the less 1 as a parent of the 0. No, I think that where Q is empty, negative, in this case I add the 0 as a I remove it. One. And I add this. No, here. If the node is 0, no, let me come back to this. For example, this is 0, is one iteration. Give me the children of the 0, that is only the 1. The 1 has been processed before, no. Add in the queue, and only the first time I need to do this operation, only the first time. And I don't need remove, it's only pick. Yeah, know what is the value of the first. Why? Because in the next time, basically I start with the 1. Or for example, do you imagine that I start here, I add 2 values, but the node have this value. Now take this. No. I think that I need to do a simple BPS and stop and apply have a one conditional with that if, and where the value current node is equal to the Bob node is a return, and that's it. Yeah, I think that is more easy in this way. So that is empty, negative, and now it is okay, here is not empty. I add the 0, I remove the 0, and I am saying that give me the nodes of the 0. In this case, is the children of the 0 is only 1. Okay, this 1 is add, and come back again. But this node is here, and in this, yeah, this is simple. Bob node. When happen this is return, but I think that previously I need to save the values, because you remember that I need to have the node and parent, node and parent. Like this. Yeah, in this case is Bob map. Output node in his parent. No, I think that is here, because in this moment I know the node that is the parent and the children is this. Yeah, I think that here I don't need to do anything, because has been saved before. Yeah, in this way I have for example, I reached the 3 as a stop, and now it's enough only start with this 3 and basically following the parents. Okay, now Bob method put pointer as one. Yeah, sure, it's this. In this case, the node is 0. It's Bob pointer. Bob and the steps. I think that this, it's not necessary here, not yet. And it's only this, the Bob. Now here in this moment, I know what is the path. It's enough only with this. I'm not sure what is the conditional, but inside them is take a parent equal take a parent, it's equal Bob map get or default. Okay, I know what is the default, what is the conditional, where this it's different. Perform this operation until a parent different less one, and in which moment appears the less one. In this case is here, where reach the zero. Basically, the zero don't have parent, and in this moment return the default that is zero and is stopped. Yeah, and in this case, for example, now is in here I need the Bob steps, Bob step map, and in this moment is I am saying that Bob no. No, 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 no. I think that pointer could be Bob, only for don't lose the value of this. No, I think that no, this is not necessary because after this, Bob disappear completely this code. No, it's good at this. Bob, where Bob is different than less one. So this, no, in this case, Bob is zero. No, is 3. Huh? Now I need to put the node and the number of steps. That is, in this case, is 1 because it's starting in 1. Yeah, I am saying that in the node string, the number of steps is 1. Now I need to know what is the parent of the Bob. In this case, the parent is the 1. And here, Bob steps plus plus increase. Now this have the value of 1, increase in 2, and come back. Bob is different than less 1, yeah, because it's 1. Okay, now the 1, why I put 3 here? This is Bob. Is it's Bob. The numbers that now in the node 1, node 1 have 2 steps. Now Bob, what is the parent of the 1? 0, and this is 3. Now Bob is different at 0, that less 1, yeah, because it's 0. Okay, I saved Bob 0 with 3 steps. I get the parent of the 0 that in this case doesn't exist. The default is less 1. I return less 1, this increase, and in this moment is stop. And sync, but clear. I think that I can clear the yeah, I think that only with clear. I think this and yeah, only for free the memory. I think that I can use this, but to be honest, it's not necessary. Where? I think that here. No, is defined. Where? Here. Okay. I know that is not the best solution. Yeah. Okay, I think that it's enough. In the next transmission, I will check the answer because I spent many time in this problem, but I think that I was in the right, well, I am in the right way, I think. But well, thanks for following this transmission, and I hope see you in the next. Bye-bye.